A large insurance company with a strong center of excellence is using Power Platform and the provided COE toolkit to start a company-wide initiative to improve business processes and reach $5 million in total cost savings annually. Employees within the company receive an email sent through the COE toolkit with a link to the Innovation Backlog to add ideas on inefficiencies within their business processes to help the COE team with discovery. Employees can add an idea to the backlog, including the people that are impacted, the tools that are being used, the ROI that will be improved, existing workflows of the process, and the complexity of the process based on various factors. For measuring ROI, the Innovation Backlog provides preset entry forms for estimating dollar impact based on time spent, total number of people, the average wage, and estimation of time spent per week. Once an idea is submitted, it will be ranked by ROI and complexity amongst the other submitted ideas, providing COE team with not only a great starting point for which business processes to go after, but also some understanding of the ROI as well as the complexity. Copilot recommends creating a cloud flow for approval, and by clicking on the suggestion, we're taken to the natural language to flow creation experience, where we can see what Copilot generated for us as suggested flows. This is a good starting point, but Copilot does not have the detailed information on how the approval is conducted, and neither does the process analyst. For this, we need to involve the business users and task mining to understand the approval activity on a more granular level to help us with automation creation. Let's start by using Power Automate Process Mining's task mining capability, where we'll be able to learn the manual interactions and applications involved for settlement approval. After creation, I can either create a new recording myself or open the process details to share the process with others. We can share the process with other business users as contributors who can only add recordings and nothing else, or co-owners who can assist in labeling recordings as well as view analytics. Business users will create new recordings using Power Automate Desktop, available out of box in Windows 11. The easy-to-use recorder will capture the details of the desktop interactions, including interaction type, the UI element, the window, the app, and other metadata for each action. As we add more recordings to the process, we can create the business taxonomy for approval so that there will be alignment across recordings. And once we complete the required recordings, we can open each recording to see that actions are auto-grouped using AI grouping and labeling functionality. We can click on each action to see a detailed description, as well as a screenshot to get a good understanding of what they did, including what seems to be a bespoke legacy invoice app, which will likely require RPA to automate. We can also edit the grouping, like changing the AI recommended group name to the ones that we created in the business taxonomy. Once we are done with recordings, we can analyze the process to generate the process map. In analytics, we can see the sequence and details of this process and how they diverge across the team. First, the approval request is opened either from Microsoft Forms or email. Then, the settlement document is open. Then the invoice data is extracted from the legacy invoice app. Settlement data and invoice data is matched with the entries in SAP. And finally, after approval, notification either happens in email or Teams. From the process map, we see that there are some variations in the order of activities, as well as some variants using email instead of Forms and Teams, which can certainly be streamlined for automation. Not only are we able to see the steps, but we can also switch to the application view where we can see the usage of various applications captured, including application switching, where constant switching between multiple applications signal some repetitive action like copy and paste. Our task mining solution even includes an AI-powered recommendation engine to use all of that recorded metadata and recommend Power Automate connectors that can be used in automation. We see recommendations for each activity, including Forms for getting the invoice approval requests, SharePoint for extracting the settlement document, SAP ERP for the matching step, Teams for notification, and desktop flows for steps that require RPA, like the legacy invoice app. By incorporating the invoice approval flow that Copilot recommended with the specific actions from task mining and AI connector recommendations, we're now able to create the full automation flow for settlement approval. We see the flow triggers whenever a new approval is submitted in Forms. We use the pre-built document extraction AI builder model To extract data from the settlement PDF, we get the relevant SAP invoice using the pre-built SAP flow templates as a child flow, and finally, we match the data across all sources. If it matches, the flow will update the invoice as approved in SAP and post a message in Teams to notify payment team of auto approval. The pre-built flow templates were added after Power Automate's acquisition of Clear Software and really simplifies a lot of the complexity for interfacing with SAP, so you don't have to build all of that complex logic yourself. With the flow created, we can test the automation by creating a new form request which will act as the trigger. We can enter a sample invoice request and go back to the flow to see the execution of actions in real time. We were even able to use the machine feature to run the RPA flow interfacing with the legacy invoicing app on our desktop machine, where the app opens and automatically selects the corresponding invoice to get the data before it returns. Finally, after matching and automatically approving in SAP, a notification card will automatically show up in Teams if the amounts match. From testing, we see that this is much more efficient and runs in just a few minutes compared to the manual approval process it is replacing, which takes over 30 minutes on average. In the Process Compare tool, we can choose the late payment view to compare with our on-time payment view. And in the output, the green activities and edges are those that are shared across both views, while the red is only present for late payments. We see that 3 claims were late because it required reapproval, but it represents an edge case. Absolute numbers are not very useful here, so let's look at percentages instead. Now we see something interesting. While the frequency of other activities is not very different between late and on-time payment, late payments have a much higher frequency of escalation at 54%. Drilling in, we can see that there is a much higher likelihood of escalations, 68% for late payments versus 14% for on-time. This is a great insight, but escalations are not something we can simply avoid, and there are various reasons why escalations occur. What we really want to do is predict whether a claim will be paid late. Let's ask my assistant on what to do. Copilot recommends a variety of actions to assist in our goal. Some of them we've already done, but it also recommends doing a root cause analysis and then building a predictive model using historical payment data as training sample. This is great. Let's start with root cause analysis, or RCA, on finished cases. I can select late payment as my metric and only the influencing factors from my data. And RCA shows me that region is the most influential factor, where a subset of 30 regions account for the majority of late payments. In addition, I can look at other influential factors like claim type, where one specific claim type is causing more late payments than others. I can also continue to drill into other influential factors, like within those 30 regions, lower amounts actually contribute to higher likelihood of late payment. Now that we have a good understanding of the influential factors, let's build our predictive model. I can export my historical process data at the case level with the relevant columns as well as my late payment custom metric, and easily import it into Dataverse as a new Dataverse table, where you can see it correctly detected the columns and data types using Copilot. I can then navigate to AI models and create a new prediction model. Use the table that we just created and late payment as the outcome we want to predict. Through a simple low-code intuitive interface, I'm able to start training my model. Once the model is trained, I can review its performance, which has a rating of B and correctly predicted 87% of actual results. And the most influential factors are aligned to what we discovered from RCA, including region, cost, and claim type. Let's publish it and use it in a flow. I can create a flow with the help of Copilot to trigger on a new claim settlement, then use the AI model I just created, provide the relevant data as input to the model, and if the prediction response is true, send a Teams notification to expedite the claim to ensure on-time payment. I can verify the flow runs correctly by testing it and seeing the results in my Teams notification channel. Let's use that data to build out a custom Power BI dashboard to monitor issues and track improvements. We can publish the process directly into our existing Power BI workspace. Once the process is linked, we can navigate directly to the generated report in that workspace. From here, we can edit the report and access all of the data that was generated by process mining. I'm able to create custom reports for compliance and automation and track all the relevant KPIs. We can even add those metrics from the report into a scorecard through Power BI Goals and set up alerts to notify the team when a Power BI goal has been reached. We ask Copilot to help find the bottleneck, and it tells us that variant 12 is the longest running variant. Using the interactive dashboard and focusing on variant 12, as well as changing to performance view, we can see that nothing happens for a long time after the handler is assigned, and the process resets and goes back to the coverage check step after a day or two. This is a great insight. Not only can Copilot help me uncover insights and identify bottlenecks, it can also provide suggestions that help address these bottlenecks. One suggestion is a Power App that allows customer service reps to assign handlers more efficiently based on their caseload. Clicking on the suggestion takes us to the Power App's Copilot experience, where it uses the app suggestion from process mining to generate the actual table in Dataverse, as well as the interface that connects to the table using natural language. Now, all we need to do is connect the table to the underlying system.